Okay, so just a quick note on 1.5, number 31. So here we're given the equation C equals 50 plus 0.12 times D, where D is the number of gigabytes used and the cost quote given is $1,850. So the question is, how do we set this up to solve for D, the number of gigabytes used, when the cost given is $1,850? So first what we want to do is substitute all the values that we know. So 1850 is going in for C, and everything else is staying the way it is. Now we're being asked to solve for D, so that means we need to isolate D. So isolating D means stripping away all the other things on the side of the equation with D. So what do we have on this side? Well, we have a 50 being added to a 0.12 times D. So we have multiplication here, and we have addition. So we typically take care of subtraction first. Let me write this all out, give some space. So first we typically subtract those constant values first, because it makes things nicer to do. If we do this, we see, okay, 50 minus 50 on the right-hand side leaves us just with 0.12D using the balance principle. And then on the right, or on the left, goodness, on the left, 1850 minus 50 is just 1800, right? So now we're left with 1800 equals 0.12D. How do we solve for D? Well, just like we would with any other equation, if we have something times the variable, in order to get it by itself, we're going to divide both sides by 0.12, or you can multiply it by the reciprocal. Right? Another way to think about it would be multiplying it by 1 over 0.12 is how you saw me do it in the other videos. And that's okay too. It's equivalent, meaning it means the same thing. So the 0.12 will cancel on the right-hand side. We'll be left with just D over here. And then 1800 divided by 0.12, well, we don't have that offhand, so we'll use a calculator real fast. So in our calculator, we do 1800 divided by 0.12, or 1800 times 1 over 0.12. And this should leave us with 15,000. This is just some side work over here. So we get 15,000 equals D. So this tells us that 15,000 gigabytes were used at a quote for $1,850. So just to highlight here how this is similar to other questions we've done, we had C equals 50 plus 0.12D. I just want to show how this is exactly the same if I had Y equals 2 plus 4x. And over here we said, right, C was 1850, and then we were able to solve for it. And we did that above. So I'm just kind of playing with this idea here. So we had this initial kind of setup. I'm saying this is actually exactly the same problem as if I had Y equals 2 plus 4x. And let's say I said we know Y is 8. And we're saying solve for x. Well, if we know that over here in this separate problem that Y equals 8, I plug this in here, equals 2 plus 4x. And then how would I solve for x here? Subtract 2 from both sides. cancels here. We're left with 8 minus 2 is 6 on the left, equals a positive 4x on the right. Positive because it has that plus sign right there. And then I divide both sides by 4 or multiply both sides by 1/4. Right, so we see that these 4's cancel. 6 over 4 really reduces to 3/2 or 1.5. And so you see how this is exactly the same problem in that we had to substitute in the y value, subtract any constant terms by doing this, subtracting this from both sides, and then dividing by the coefficient or multiplying by the reciprocal, which we did here. We did all those steps here. It's the same problem, just the numbers are different. And so once our brain kind of wraps itself around that process, this becomes less difficult in each instance. It's really, we just need to remember how to deal with these problems in general. All right, and the second question was on 1.5, number 33. So the equation is m equals 44x over 5. So we have this fraction coefficient. You know that x is the volume in the tank in liters. And we know it needs 880 grams of CO2, and that goes in for the mass. Okay. So certainly here we're going to substitute in this for the mass, which is m. And then we're going to be solving for the volume in the tank. Why? Because this is unknown. And so we're looking for the value of x that makes this true. So we plug in 880 for the mass and then solve. Now here is a couple ways to solve for x. Because we have a fraction involved, there's a few ways to write this. I'll show you the 3 main ways, and I'll show you what I do. So one thing you could do is you could multiply both sides by 5 in order to cancel out this denominator of 5 on the right hand side. Using the balance principle, we do the same thing to both sides, and then 880 times 5 becomes 4,400 equals 44 times x. And then to solve for x, since this is 44 times x, we would multiply both sides by 1 over 44 or divide by 44 on both sides so that these cancel. And I'm left with x equals 1/44 times 4,400. You could do this in your calculator and see that this works out to be x equals 100. So that's method 1, to kind of undo that fractional coefficient. But a way to do it in one shot, so if you think about it like this. So we had 880 equals 44x over 5. So if we think about this fraction for a second, 44 times x over 5. Here's a place where unsimplifying really helps. Meaning, if I thought of this as, instead of 44 times x over 5, as 45, or 44 times x over 5 times 1. Or to say that a little bit better, 44 over 5 times x over 1. First of all, see why that's equivalent, right? Go backwards on this equal sign and see that that's the case. You're asking, why would I do this? Well, if I write it like this, what's x over 1? This is really 44/5 times x. And so if I view it like this, and this is a really helpful thing to do with fractional coefficients like this one, then in this equation I get to see this 44/5 as the coefficient, and then in order to reduce it on both sides, I can do it in one shot by multiplying by the reciprocal 5/44, just like we've been doing up here. But I do it in one shot, 5/44. What happens? The 5's cancel, the 44's become 44 over 44, we're just left with 1. And so I get x on this side, and then everything else is on the left. So 880 times 5 over 44, if you do this in the calculator, you get the same answer, you get 100. This is how I would do it, and this is how I do it. One reason is because it's helpful to think of variable expressions that have fractions like this, and it takes care of all the work in one shot. You don't have to do 2 steps. So I hope that helps. Again, very similar problems in that we are substituting in for one value and then solving for the other using the balance principle. And they are really very similar in process, and just the numbers can be different. So just don't lose sight of that fact.